Now let's take a look at factoring. In particular, let's look at the greatest common factor and the concept of factoring by grouping. When you multiply a polynomial expression, that's done by distributing. So let's say we have x plus 5 multiplied by x minus 3. To multiply, we would take x times x, which gives us x squared, x times a negative 3, which is minus 3x, 5 times x, which is a positive 5x, and 5 times a negative 3, which is a negative 15. And then you would combine your like terms. Here, x squared is the only squared term, so it doesn't combine with anything else. But these two are like each other. They're both first degree terms. So 5x minus 3x combine to give us plus 2x. And then you have a minus 15 as a constant. Now, whenever you have something like this, where you have x plus 5, that's a polynomial, multiplied by another polynomial, you get an answer like x squared plus 2x minus 15. Putting these two together is called distributing. You can also just say it's called multiplying, because that's what we're doing. We're multiplying these together. But there are times when it's useful not to have it put together. Sometimes it's useful to have an expression where instead of having this as a single polynomial, you've broken it apart into two or more smaller polynomials. Going in this direction, putting it together, is called distributing, or you can also just call it multiplying. Taking something that's already put together and separating it out into two or more small polynomials, that's called factoring the polynomial. Now, factoring is not a single skill. It's not a single technique. Rather, there are different kinds of techniques, different kinds of results that can all be considered as factoring. So here we're going to look at two different techniques which both fall under the category of factoring. There are plenty of others, but we're going to start off with just these two. So the first one we're going to talk about is the greatest common factor. So first we're going to talk about how to find the greatest common factor, then we're going to talk about what to do with it. The greatest common factor, first of all, is a long phrase to say. No one wants to say that whole thing. So it's often abbreviated as GCF. It's easier to write, easier to say. Greatest common factor, GCF. All right. So the greatest common factor is the biggest factor of all terms of the polynomial. Now remember, factor, it means things that are multiplied together. Just like when you add two things together, 2 plus 3, these are both called the addends. Addends are things that are multiplied together. If you multiply two things, these are called factors. So that's why it's called factoring, because you're trying to separate it into the product of two things, this times that. Okay. So now, among your terms, you may have factors which all the terms have in common. When you find the biggest factor that all terms have in common, that's called the greatest common factor. So first of all, let's talk about how to find that. And let's start with an example. Let's find the greatest common factor of 18x to the third power plus 48x to the second power, like that. All right. What we're going to do is we're going to take each of these and break them apart as far as we can on their own. Now, what do you mean break them apart? We're going to use a prime factorization. So the number 18, what we want to do is we want to find all the prime numbers that multiply together to give us 18. So here 18 can be written as what? 2 times 9? Okay, well, 2 is a prime number, but 9 is not, because 9 can be factored some more as 3 times 3. Oh, but 3s are prime numbers. Okay, so then that means that 18 is written as 2 times 3 times 3. All right? Not the 9, just the prime numbers. We can do the same thing for 48. If we take 48, 48 can be written as what? I can say 2 times 24. Okay. 24 is 2 times 12. Okay. 12 is 2 times 6. Okay. Again, 2's are all prime numbers, but 6 can be factored some more as 2 times 3. Okay, so 48 is equal to 2 times 2 times 2 times 2 times 3. All right. So now I'm going to think of 18x to the third power in the following way. 18x to the third is, well, 18 is these numbers right here multiplied together. 2 times 3 times 3. Now, x to the third means x times x times x, like that. I want to do something similar to 48x squared. 48x squared, again, the 48 is 2 times 2 times 2 times 2 times 3. And then x squared is x times x. So now these are all the factors of 48x squared. They're all the things that are multiplied, all the factors to give me 48x squared. And these are all the factors of 18x to the third. Now, one thing you'll notice is that they are different collections of factors. But you'll also notice that some of these are the same. They have some of them in common. All right, so what do they have in common? Well, let's see. I have, well, both of these lists have a 2. And they both have a 3. Okay. Now, these have more 2's, but this one doesn't. It has to be something that's common, something they both have. And look, they both have a pair of x's. So, when I put all that together, the 2 times the 3, notice they had a 2 in common, they had a 3 in common, and they had a pair of x's in common. So right now what I'm listing is all the stuff they had in common. They both had a 2. All right, so I write down a 2. They both had a 3. Okay, so I write down a 3. They both had an x squared. Okay, so I write down an x times an x. Now, if I multiply this together, what do I get? Well, 2 times 3 is 6. X times x is x squared. This is the greatest common factor. So to find the greatest common factor, we factor out the coefficients into a prime factorization. We can write out the variables just by listing them. And then we look for all the things they have in common. When all of those are multiplied back together, that's the greatest common factor. Okay. Let's see that again. Let's use another example. Let me do that with 3 terms this time instead of just 2. So let's consider 24x to the 5th minus 72x to the 3rd plus 60x squared. So I'm going to go ahead and do the same thing. I need to factor out my coefficients. 24x to the 5th minus 72x to the 3rd. We really only worry about the number. Don't worry about the sign here. It's not that the sign is meaningless. It's just we don't worry about it for this step right here. Okay. And then we're going to take 60x squared, and we're going to factor everything out. All right, so let's start with the numbers. 24. All right, well, 24 is, I can say 3 times 8. 8 is 2 times 4. Notice 3 and 2 are both prime numbers, but I can factor 4 a little bit more as 2 times 2. So 24 is going to give me 2 times 2 times 2 times 3. And then x to the 5th is 5 copies of x multiplied together. All right. And then I can move on to the next one. 72. Let's see, 72, that is 2 and 36. 36 is, that's a prime number right there. 36 is 6 times 6. And then each of those 6's can be factored as 2 times 3. All right, so that looks like that's 2, 2, 2, 3, 3. 2 times 2 times 2 times 3 times 3. And then x to the 3rd means 3 copies of x multiplied together. And finally, 60x squared. Well, let's see here, 60. 60 is 6 times 10. And I know the 6 can be factored as 2 times 3, which are both prime. And the 10 can be written as 2 times 5, which again are both prime. Okay, so that's going to be 2 times 2 times 3 times 5. And then I have my x squared here, which is just x times x. All right, so I've gone ahead and factored out all of my terms, which means I can now look for what they have in common. Let's see, they both have a 2. In fact, look, they both have they all have a pair of 2s. They say, well, look, these have 3 2s, right? But that would leave this one out. It's got to be something they all have in common. So here, they all have a pair of 2s. Yes, it's true. These also share another 2, but that one doesn't. So it's got to be something that they all have. So they all have a pair of 2s. It looks like they all have a single 3 in common. And it looks like they all have a pair of x's in common. All right, so there we go. So let's put that all together. The greatest common factor, the GCF, is going to be 2 times 2. Right? They all share a pair of 2s. They all share a 3, so 2 times 2 times 3. And then they all share a pair of x's, so times x times x. So that's going to be 2 times 2 is 4. 4 times 3 is 12. And then x times x is x squared. So this is our GCF. So go ahead and give this a try. All right, so let's go ahead and find the greatest common factor. Go ahead and give this a try. Find the greatest common factor of 84x to the 5th power plus 147x to the 4th power minus 126x to the 3rd power. All right, go ahead and pause the video, give that a try, and once you have found the greatest common factor, go ahead and unpause and we'll go through it together. All right, so let's take a look. We're going to take our 84 x to the 5th. We're going to take our 147x to the 4th. And we're going to take our 126x to the 3rd, and we're going to factor out the coefficients. So let's go ahead and factor out 84 first. Let's see, that's an even number, so I can write that as 2 times 42. 42 is 6 times 7. And then 2 is a prime number, and so is 7. But I can factor 6 as 2 times 3. All right, so there we go. 84 is 2, 2, 3, 7. Remember, we only worry about the prime numbers, not the 6 or the 42. 2, 2, 3, 7. And then x to the 5th is 5 copies of x multiplied together. All right, let's try the next one. We're going to take 147. Notice 47 can be divided by the number 7. Because if we divide that by 7, that's what? 2 and 1? That's 21. Okay, so 7 is a prime number already, but 21 is 3 times 7. All right, there we go. So 147 is 3 times 7 times 7. And then x to the 4th is 4 copies of x multiplied together. Finally, 126. Well, let's see, that's an even number. So that's 2 times what? 63. Oh, and 63 is, what is that? 9 times 7 is 63. 7 is a prime number, but the 9 can be factored as a 3 times another 3. So 126 is 2, 3, 3, 7. 2 times 3 times 3 times 7. And then the x to the 3rd has 3 copies of x multiplied together. All right. So now let's see what they all have in common. Looks like they all have a 7. They all have a 3 in common. Notice that these have a 2 in common, but that would leave out the middle one. You can't do that. It has to be common for all of them. They all have to have one. So here they all have a 3, they all have a 7, and it looks like they all have 3 x's. Now, these have more, but that would leave out the bottom one. It's got to be the same for all of them. So then our greatest common factor is equal to 3 times 7 times x times x times x. Or in other words, it's 21 x to the third power. And that makes us happy. That's our greatest common factor. Now, what are we using these for? What is the interest of finding a common factor, a greatest common factor? Let's go back to the problem that I did before. What we're trying to do is we're trying to take a polynomial and separate it into two smaller factors, two smaller polynomials that multiply together to give you the big one. Well, notice what that means. Anytime I factor, I'm supposed to have at least two factors. One polynomial will break apart into two other ones. Okay, so here's one big polynomial. How do I break it apart into two smaller ones? One of the two smaller factors will be the greatest common factor. So here, we're going to continue on to factor this. The way you factor it is you take the greatest common factor, and that's your first factor, 6x squared. You say, yeah, but you need two of them, right? That's one of them. Where's the other one coming from? What you're doing is you're dividing these by your greatest common factor. Because remember, by the time you're done, you want two things that multiply to give you the polynomial. Okay, so going this way, you're multiplying. To come back this way, you're dividing something out. Okay, so if I take 18x to the third and I divide it by 6x squared, 18 divided by 6 is 3. X to the third divided by x squared. Remember, when you divide two things that have the same base, subtract their powers. 3 minus 2, that's x to the power 1. Plus, we take 48 and divide by 6. That gives us 8. And then notice if you take the x squared and divide by the x squared, they just go away. X squared divided by x squared is the number 1. So really that's 8 times 1. All right, well, there we go. This is a factorization. The factorization is the product of the greatest common factor and what's left when you divide out the greatest common factor. Notice, if you were to multiply this back out, what would you get? You would get 18 x to the third plus 48 x squared, which is exactly what you're supposed to get. If you were to multiply them back out, you should get back the big polynomial. Looking at the next example, you have pretty much the same thing. Let's continue on. We know what the greatest common factor is. Let's use that to factor this polynomial. Okay, so this will equal to our greatest common factor, 12x squared, times, we're going to go through and divide everything by 12x squared. 24 divided by 12, that's 2. X to the fifth divided by x to the second is x to the third. You subtract the powers. Minus 72 divided by 12. That's going to be 6. And then you have x to the third divided by x squared. That's just x. And then you have plus 60 divided by 12 is 5. If you divide x squared by x squared, you just get 1. So 5 times 1, we can just leave that as 5. And this is a factorization. We've taken one big polynomial and separated it out as two smaller factors. Notice, these two factors have smaller numbers. They have smaller powers. Power 5 versus powers 2 and 3. This will be useful to us in solving equations. Solving equations that have large expressions is complicated. But when we separate them out into smaller expressions, those equations are much easier to solve. We'll see that later on down the line. But for now, we're working on how to factor our polynomials. So go ahead and give this a try. You already found the greatest common factor. Go ahead and use that and finish the factorization. What is this equal to? This equals to, so the second part of the directions, find the GCF. Then factor. All right. So go ahead and give that a try. You already know what the GCF is. Finish the problem and factor. Go ahead and pause the video, and once you're done, go ahead and unpause and we'll go through it together. All right, so here we go. That's going to equal to 21x to the third power times whatever's left when we divide. 84 divided by 21, that's just the number 4. X to the 5th divided by x to the 3rd is x squared. Plus, if you take 147 divided by 21, you get the number 7. X to the 4th divided by x to the 3rd is just x. And then you have a minus right there. 126 divided by 21, that's just the number 6. X to the 3rd divides x to the 3rd, and that just goes away. It's the number 1, and 6 times 1 will just stay 6. So there is your result. This is the factorization that you get by factoring out the greatest common factor. So go ahead and give that one more try. Do it all the way through now. Factor out the greatest common factor. Basically do both of these steps, but all in one. Go ahead and find the common factor and then perform the factorization. All right, so give this a try. Let's do 54x to the 4th power minus 90x to the 3rd power minus 108x to the 2nd power. All right, go ahead and pause the video, find the greatest common factor, and then complete the factorization all the way out to this. All right, once you have a result, go ahead and unpause and we'll go through it together. All right, so let's give that a try. We're going to go ahead and factor out these terms. Let's see. 54x to the 4th power, 90x to the 3rd power, and 108x to the 2nd power. Let's start off with the coefficient 54. Let's see here. 54 is 2 times 27. Now 2 is a prime number, but 27 is 3 times 9. And 3 is a prime number, but 9 is 3 times 3. Just like that. Okay. So here 54x to the 4th is 2, 3, 3, 3. And then 4 copies of x multiplied together. 90, let's do that next. 90 is 9 times 10. Now we know 9 is 3 times 3. And we know 10 is 2 times 5. And those are all prime numbers. So it looks like 90, x to the 3rd, is going to be 2, 3, 3, 5. I always put them in order from the smallest to the largest, but that's just a personal habit. If you just wrote down these numbers as 3, 3, 2, 5, that's fine. It doesn't matter what order they're in as long as you have those numbers. A 2, a pair of 3s, and a 5. The order doesn't actually matter. The x to the 3rd is x times x times x. Okay? And then 108, that's 12 times 9. 12 is 2 times 6, and I know 2 is prime already, but 6 can be factored as 2 times 3. And then this 9 factors as 3 times 3. All right, so 108 is going to be 2, 2, 3, 3, 3. And then the x squared is x times x, just like that. So now we look for what they have in common. They all have a single 2 in common. They all have a pair of 3s. And they all have a pair of x's. Notice these have 3s in common, but that will leave out the one in the middle. We can't leave anything out. These have more x's in common, but that will leave out the one on the bottom. So we can't do any of those. So our greatest common factor is what they all have in common, which is a 2 times a pair of 3s times a pair of x's. Which is, let's see, 2 times 3 is 6. 6 times 3 is 18. X times x is x squared. So that's my greatest common factor. And so now I'll use that to complete my factorization. This is equal to 18x squared. And now the remaining factor is whatever's left once I divide out by 18x squared. If I take 54 and divide by 18, I'm left with 3. X to the 4 divided by x to the 2nd is x to the 2nd. Minus I've got 90 divided by 18, that's the number 5. But then x to the third divided by x squared leaves you a single x, minus. If you take 108 and you divide that by 18, you get 6. The x squared divided by the x squared is just 1. So 6 times 1, we'll just write that as 6. And that is our factorization. Note if you got something similar to this but with a smaller number, maybe you got 9x squared here, and here instead of a 3, a 5, and a 6, you had a 6, a 10, and a 12. That's not exactly wrong, but it's not complete. Because remember, the greatest common factor means the greatest, the biggest. If you got something smaller than 18, you didn't get the greatest common factor because it's not the biggest it could be. Right? So keep that in mind. When you factor out everything. If you got 9x squared here, or 6x squared, or 3x squared, or anything smaller than these numbers, that's not sufficient. That is not the greatest common factor. You're not exactly wrong, but that's definitely not complete. Okay. As a quick note, there is often occasion to factor out a negative. You say, a negative what? Just the negative. So, for example, let's say we're going to factor out the GCF. Let's say we have, let's keep our numbers simple, negative 9x squared minus 6, minus 6x plus 12. Okay. These numbers are simple enough. The greatest common factor, probably come up with it fairly quickly. Yeah. If not, we can always factor. 9 is 3 times 3. 6 is 2 times 3. And 12 is 2 times 3. So our 9x squared, that's 3 times 3 times x times x. Our 6x, that's going to be 2 times 3 times x. And our 12 doesn't have a variable. It's just 2 times 2 times 3. And the only thing they have in common is the number 3. Notice these don't have a common x, which is fine. You don't have to have any common variables, just whatever you have in common. All right? So right here, what we want to do is we want to factor out the number 3. But before we do that, one thing to note is this leading term has a negative in front. What we want to do with factoring is we eventually want to use it to solve equations. And for reasons which will come about later, whenever you solve equations, having negative lead terms, having negatives at the front, makes things just ever so slightly more complicated. So as long as we're taking things out, oftentimes it's useful to take out a negative. So here's how this looks. We say, okay, look, we want to go ahead and factor out the 3 because that's the greatest common factor. My GCF is 3. Okay, so let me write the 3 in front. But you know what? I want to go ahead and factor out a negative. I want that negative out of here. Okay, that's fine. Go ahead and put it with the negative. Go ahead and put the negative with the greatest common factor. Once again, your greatest common factor was just the number 3. But since we're also trying to get rid of this negative, we can factor that negative out as well. So instead of thinking of this as being 3, we think of it as negative 3. But now to complete the factorization, we're dividing all of this not by the original 3 that we had, but by a negative 3. And by dividing by a negative, that'll turn this to a positive, which is what we want. So if we divide negative 9x squared by negative 3, we get positive 3x squared. If you divide negative 6x by negative 3, we get positive 2x. Negative divided by a negative is a positive. And here if you take 12 and divide by negative 3, a positive divided by a negative, that's a negative. 12 divided by 3 is 4. And that's our factorization. So keep that in mind whenever you have a lead term which has a negative coefficient, whenever you have a negative lead coefficient, when you factor out the greatest common factor, it will often be the case that you want to go ahead and factor out the negative of that factor. All right? This greatest common factor is 3, but we ended up factoring out the negative of that, negative 3, to make this positive. Now, there is another related technique for factoring, Here we've taken out the greatest common factor. Let's talk about something called grouping. We're going to factor by grouping. Now, grouping is kind of specialized. Over here, we saw that we could factor out the greatest common factor if you have 2 terms or if you have 3 terms. And although we didn't go any further into it, we could factor out a greatest common factor if you have 4 terms or 5 or 6 or really any number of terms. Grouping is a little more specialized. It can only be done if you have 4 terms. Technically, it can be done with 6 terms, but we're not going to worry about that. For us, it should be 4 terms. Now, in reality, factor by grouping can be tried anytime you have any even number of terms greater than or equal to 4. So 4, 6, 8, 10, 12, any of those are possible, but we're not really going to look at those. We're mostly going to just fixate on these because once you know how to do it with 4 terms, it works pretty much the same way for any number of terms. So 6, 8, 10, 12 are all valid, but we're just going to focus on these. All right, so let's see how to factor by grouping. Let's start off with an example of x to the third minus 6x squared plus 5x minus 30. Okay. Now, one thing you might note here is that you don't have a greatest common factor. All of these terms have some common factors between one another, but there is no factor that's common for all of them. You can even check that. Here, x to the third power is, well, it's just 3 copies of x multiplied together. I don't even have a coefficient. Okay. 6x squared, well, 6 is 2 times 3, and those are both prime numbers. And then the x squared is x times x. 5x is, well, it's 5 times x. Right? 5 is already a prime number. And 30, well, let's see, 30 is 3 times 10. And then that 3 is prime, but the 10 can be factored as 2 times 5. So 2, 3, 5. Like that. And you'll notice that they don't have anything in common. Sure, these all have x's, but that leaves out the last one. And these have 2's and 3's, but that leaves out the first one and the third one. And then both of these have a 5 in common, but that leaves these out. So there is no one factor that's common to all of them. So here we can't find a greatest common factor. Well, notice that there is a greatest common factor between these two. They both have a 5 in common. And notice that you have a greatest common factor between these two. They both have a pair of x's in common. But you say, well, yeah, but that's not good enough because it has to be common to all of them. Well, that would be true for a greatest common factor. But here, with grouping, what we're going to do is we're not going to look at the entire polynomial at once. We're going to separate it in half. That's why we want to have an even number of terms, right? 4, 6, 8, 10, or 12. Again, we're going to focus just on 4. Because we want to be able to split the polynomial in half, which means we need an even number of terms so that each half has the same number of terms. So let me grab a couple of colors and let's separate this out. With grouping, what you want to do is you want to look at the first 2 terms on their own. Forget about those. We'll worry about those later. Looking at just the first 2 terms, what's their greatest common factor? Oh, well, it looks like they both have a pair of x's in common. Okay, so that's the greatest common factor, x times x, which is x squared. Okay. Now, if we divide these terms by x squared, again, not these, just this stuff over here, just the first half, x to the third divided by x squared is just an x. If we take minus 6x squared and divide out the x squared, these two divide away, and you're just left with your minus 6. Okay. Well, now what about the other 2 terms? Well, let's look at those together. 5x minus 30. What's their common factor? Well, they have a 5 in common. Okay, so now is that a positive 5 or a negative 5? That's a positive 5. Okay, so I'm going to put plus 5 right here. Remember, these are not multiplied. These are all terms that are added. So here this needs a plus or a minus. In this case, that's a plus. Plus 5. And now we're going to divide each of these by the number 5. Okay, well 5x divided by 5 is just the x. And negative 30 divided by 5 is negative 6. Okay. But now look at the stuff in the orange. Look at the stuff in the green. Do you notice that they have something in common? They both have a factor of x minus 6. But when you have a common factor, that's what this is. It's common to both of these terms. There's one term in orange. Here's another term in green. Both of these terms have a common factor. Well, then the common factor is factored out. Just like in our previous examples here, all of these had a factor of 21x to the third. So that gets factored out, and we write that down in the front. Okay, well, here, between the green and the orange, they both have an x minus 6 as a common factor. So I will factor it out and write it in the front. Oh, but then what? Well, once we take out the common factor, what's the other factor? Oh, what's what we get when we divide? Divide 28x to the fifth by divide 84x to the fifth by 21x to the third. That's your 4x to the third. Divide your 147x to the third by 21x to the third. That's your 7x. Divide your negative 126x to the third by 21x to the third. That's your minus 6. So over here, what happens when I divide this by my x minus 6? Well, this part goes away, and I'm just left with my x squared. Same thing with this. If I divide out the common factor, divide out the x minus 6, that part goes away, and all I'm left with is my plus 5. That's my factorization. You can check that. Look, if you multiply this, what's x times x squared? Well, that's my x to the third. What's negative 6 times x squared? Well, that's negative 6x squared. Okay, well now what's my 5 times my x? Well, that's my 5x. And what's my negative 6 times my 5? Oh, well, that's my negative 30. If you multiply these out, distribute, that gives you back the original polynomial. So that is my result. Let's see that again. Let's say we have 2x to the fourth power minus 9x to the third power minus 8x plus 36. All right, same idea. We're going to go ahead and factor by grouping. All right, so now let's go ahead and factor out these numbers. The 2x to the fourth, well, that 2 is already a prime number, and x to the fourth is 4 copies of x multiplied together. Okay. My 9x to the third, well, 9 is 3 times 3, and then x to the third is 3 copies of x multiplied together. My 8x, well, let's see here, 8 is 2 times 4, and that 4 factors as 2 times 2. So 8x is 2 times 2 times 2. There's 3 2's right there, times the x. And then 36, well, let's see, 36 is 6 times 6, and each of those 6's is 2 times 3. So I have a pair of 2's and a pair of 3's. All right, so now I'm going to perform my grouping. I'm going to take my first 2 terms and I'm going to group them together. All right, so that's these 2. And what I'm looking for is what their common factor is, just these 2. Okay, well, it looks like they have an x, they have 3 x's in common. All right, they don't have any numbers in common, just the x's. They don't have any constants in common. So here, x to the third is my common factor. So let me write that in the front. And then whatever's left is what I get when I divide. So 2x to the fourth divided by x to the third is just 2x. If I take minus 9x to the third and divide away the x to the third, I'm just left with a minus 9. Okay? So now, I'm done with that part, and now I'm going to factor this part out. Now, in a previous example, we saw that when you're factoring something out, if the lead term is a negative, we often want to go ahead and factor out the negative along with the greatest common factor. Well, that's what we have here. we already did this part. We don't have to worry about that for now. We're looking at factoring just this. Notice that's got a negative in front, which means we're going to find the common factor, but when we factor it out, we're also going to factor out the negative. So let's go ahead and do that. Looking at these two terms, what do they have in common? They all have a pair of 2's. And, oh yeah, that's it. So 2 times 2 is 4. My greatest common factor is 4. Oh, but because of the minus in front, it's going to be convenient to factor out a minus 4. All right, so let's see what happens when we factor out a minus 4. If we divide negative 8x by negative 4, negative over negative is a positive 2x. If I take 36 and divide by a negative 4, a positive divided by a negative is a negative. 36 over 4 is the number 9. So now, looking at the green and looking at the orange, I realize that I have two terms, this term in orange and this term in green, and the orange and the green term have something in common. They have a 2x minus 9 as a factor. So that is their common factor. We're going to write that down first. And then the remaining factor is what you get when you divide out these terms by the common factor. If you take x to the third times 2x minus 9 and factor out and divide out the 2x minus 9, you're just left with the x to the third. If you take negative 4 times 2x minus 9 and you divide out the 2x minus 9, you're just left with the minus 4. And that is our factorization. If you're ever not sure whether or not that's correct, if you're ever not sure whether or not you've done a factorization correctly, go ahead and multiply it back out and see what happens. If you take 2x minus 9 times x to the third minus 4, let's go ahead and multiply it out. X to the third times 2x is 2x to the fourth. If we take negative 9 times x to the third, that's minus 9x to the third. Okay, we've done this one. Let's go ahead and move on to the next one. Negative 4 times 2x, that's negative 8x. And finally, this last one here, negative 4 times negative 9 is a positive 36, which is exactly what we started with. So that does confirm that that is the correct factorization. So yes, this is our answer. So go ahead and give this a try. Go ahead and factor by grouping. Let's do 3x to the power 5 minus 7x to the power 4 minus 9x to the power, let's just say 9x, that's fine, minus 9x, I guess you can say power 1, and then plus 21. Like that. All right, go ahead and pause the video and give that a try. Once you are done, go ahead and unpause and we can go through it together. All right, so let's take a look. We're going to go ahead and factor out greatest common factors, but only one pair at a time. So let me go and do all that at the same time. 3x to the power 5, that's 3 times x times x times x times x times x. 3 times 5x's. If I take my 7x to the power 4, well, 7's already a prime number. X to the power 4 means 4 copies of x are multiplied together. If I take my 9x, well, 9 factors is 3 times 3, and then I have a single x. And then 21, well, that's 3 times 7. And that's it. There's no more variable there. All right, so now let's go ahead and find the greatest common factor one pair at a time. So let's take a look at this pair first. What do they have in common? Well, they don't have any numbers in common, but they do have 4 x's that they share. Okay, so that's my greatest common factor. I'll write that first, x to the power 4. Now, once you factor out x to the power 4, 3x to the power 5 divided by x to the power 4 is just your 3x. Right? Power 5 minus power 4 is power 1. If I take negative 7x to the fourth and divide away the x to the fourth, I'm just left with the negative 7. Okay. Now, that part is done. I don't worry about that anymore. Now I'm factoring out the common factor out of these two. Well, here, there's only a single 3 they have in common. All right, so my greatest common factor is 3. Oh, but my lead term has a negative. Whenever I have a lead term that's a negative, it's going to be convenient for me to factor out the greatest common factor along with the negative. So instead of writing 3, I'll write a minus 3 out here. Okay, so now, since I'm factoring out a negative 3, I have to divide each of these by negative 3. Negative 9x divided by negative 3. Negative over a negative is a positive. 9 over 3 is 3, and then the x is still there. If I take a positive 21 divided by a negative 3, positive over a negative is a negative. 21 over 3 is 7. And now, looking at the term in the orange and looking at the term in the green, these two terms have something in common. They both have a 3x minus 7 as a factor. So that's a common factor, which means I can write it in the front. That's my common factor. And then whatever's left is the remaining factor. If I take x to the fourth times 3x minus 7 and I divide out the 3x minus 7, I'm just left with an x to the fourth power. And if I take a minus 3 times 3x minus 7 and I factor out the 3x minus 7, I'm just left with a minus 3. And that is our factorization by grouping. And that is it for now. If anybody has any questions, comments, or problems, please make a note of those and reach out. And I hope everyone has a nice day.